we are here from Simwell to present our engineering scenario agility, our framework for tactical planning and anyLogistix. So what we're going to talk about today is who are we, the problem after your first model, Simwell's solution to that problem, and then we're going to demo our scenario manager tool. So first off, who are we? Who am I? Who is Chris? So I am Nick Geary coming out of Buffalo, New York. I am our supply chain team lead, and my role here is to take projects all the way from data to delivery. I am joined here with my colleague, Chris Shope, who's coming out of London, Ontario, and he is our senior senior software developer, and he is the one who created this framework that we're going to show off today. Next, even though you just talked about Simwell, who is Simwell? So Simwell is your simulation technology partner. We're the largest simulation optimization company in the world, coming to you from US, Canada, India, all the way to Australia. We build models to solve business problems faster, all the way from simulation to simulation, anyLogic, all the way to your digital twin. We are here to be your simulation technology partner. So last year, we talked about the beginning of the journey from data to delivery. And at the end of that journey, we talked about how you build your first anyLogistix model. And in that process, we tackled dirty data, multiple sources, and inconsistencies between that data. But now, as we've gotten to that first model, you guys presented your first modeling solution, sharing off your results. What comes next? Typically what happens is that the mountain gets a little bit bigger, and then you're peppered by leadership with more questions, which require more answers, and typically they want it now. What types of questions are they usually going to ask? So now that you shared your first results, you got your baseline, maybe one or two scenarios, so they're going to want to know, hey, what happens when we add a new DC? What happens when we add a new factory? What happens when we add more capacity at a factory or more capabilities at those existing factories? So what happens when we move production or add a new line? Here is where the next set of problems all lie. So, where does this pain come from? So usually, if you have those manual data processes or have a limited amount of trained experts who could help run those models with questionable data quality. And typically the biggest pain point here is the time to develop these different scenarios. So what's going to happen when you guys are building your models and just have a bunch of questions in your backlog of how to get there? Usually it requires more time to do that. So don't worry, Simwell has built the bridge. And today I'm proud to introduce to everyone PyChain by Simwell. I'm going to pass it off to my colleague Chris, who's going to talk about all the technology behind it, and then we're going to go into a demo of, an example of how to use it.
Thanks, Nick. So today I'll be talking about PyChain, which is an anyLogistix data pipeline toolset built with Kedro, Polars, and Pandera. First off, what is PyChain? PyChain is Simwell's signature framework for creating clean, repeatable, and modular anyLogistix models. PyChain is a Python library, and the name PyChain is short for supply chain. It contains reusable components for building ALX inputs, creating ALX inputs, building scenarios, processing ALX outputs, and visualizing the results. Next, why is PyChain? Why did we create this tool? So ALX has standardized inputs and outputs, which means that if we build shared tooling for ALX projects, there's no need to build everything from scratch, and it creates a standardized way of building our projects. It also reduces the time and effort to create supply chain digital twins, which is where we go from raw data to ALX model to experiment results to dashboards and lastly to decisions. The main libraries used by PyChain are Kedro, a data engineering framework, Polars, a blazingly fast data frame library, and Pandera, a data validation library. Next, we'll go over PyChain's structure. But first, we'll talk about the basics of an ALX project, because maybe you haven't made an ALX project yet. The first thing you do is you'll create your baseline. So in our case, that involves getting the data from the client, transforming that data into an Excel file with a specific format, which we can then import into ALX. From there, we create a scenario by making a change to the baseline model. We can then run our experiments, both the baseline and the scenario, and then compare the results of those baseline scenario from which the client will make a decision. So PyChain has two components. The first is the Python package. This contains stuff that is constant across projects and can be used directly after installing PyChain. Next is a template, has stuff that is similar across projects, where the implementation is specific to each project, but the pattern across projects is the same. So I know that's pretty abstract, but we're going to talk through what I mean by the pattern on this next slide. So Kedro has this concept of data layers, and what I'm showing here is how we've adapted that concept of data layers specifically to an ALX project. So on the right, what we're looking at, and these verticals, each of these is a pipeline where we go from raw data all the way here to model input, which for an ALX project corresponds to one of these input tables. So maybe this is the customers table, this is the demand table, and this could be the DCs and factories table. We create all those tables, and then we combine them into an Excel file where there's a table for each sheet, and then we can import that to ALX. So now I'm going to talk about each of these different layers. First is the raw data layer. This is where we read our data from the source, which could be Excel, a database, Snowflake, anything really. And that's where we will be setting our data types. The next layer is the intermediate layer, which is where you'll be doing any filtering if necessary. As you'll see in this middle one, we don't always need to apply filters, but a filter you could apply is maybe you want to filter to customers within a specific set of countries. So you could do that here in the intermediate layer. And in the primary layer, this is where you'll create new columns. So maybe you're creating the name column for your DCs and factories table. You might need to make sure those all have a specific naming convention in your ALX model so it's understandable. Next is the model input layer, which you'll be doing any aggregation. And you'll also be renaming your columns to ALX format. So that aggregation could be maybe your customers' data is at the lowest level, so it has like specific addresses for your customers. But when you're modeling, you'll be wanting to aggregate that to maybe the 3-digit zip code level. Or for your products table, you might be aggregating that to the product family level. Lastly, we have our model layer. And this is where we take each of these data frames in this case, so corresponding to one of these tables, combining them into this Excel file, and then that Excel file can be imported into ALX. Next, I'm going to talk about data sets. So Kedro has this concept of data sets, which simplify the loading and saving of data to common formats. There's a lot of data sets built into Kedro already, so you can use pandas, polars, etc., to read and write Excel, CSVs, and SQL queries. But in this case, I'm going to talk to you about Kedro custom data sets, which allow you to save and load data to less common formats. Some ALX examples of these less common formats are maybe you want to save 58 sheets to an Excel file in the proper ALX format, or you want to load all the sheets from the ALX Excel output file. So remember, ALX has those standardized inputs and outputs, and so maybe we want to take that Excel sheet, split it out into data frames so we can do some further processing. Or maybe you want to read and write data to ALX Pro Server. That can also be done in a Kedro custom data set. I'm going to talk to you about one of these custom data sets, the Excel input data set. This is the one that creates the ALX input Excel file. And what it does is it writes sheets for all 58 tables used in the network optimization experiment. It then validates those tables against Pandera data frame models. So across all those 58 tables, we have a total of 325 columns. Remember, this is specifically for the network optimization experiment. And then what the Pandera data frame model does is it runs a bunch of checks against those 325 columns to make sure that we're not inputting any bad data into this Excel file that we're then going to read into ALX. And this data set also writes empty tables if they are not created in the pipeline. So as you're building out your pipeline, you're figuring out how to programmatically go from raw data to this specific format in this Excel file. You're not going to build it all at once. You're going to build it incrementally. So you'll start by adding just one of the tables, maybe the demand table. And if you want to be able to import it in ALX, you need all of the sheets in this Excel file. And because this Excel input data set knows of which experiment is being created, it knows to get all the tables required for the network optimization experiment, for example, and then it writes all the column headers to those sheets. So we wouldn't have any data for those sheets, but we'd still have the column headers, which allows us to import into ALX. So here we're looking at the first sheet in this Excel file. So this Excel file was created programmatically by PyChain. And this looks similar to what you would have seen before if you export one of these scenarios from an example model in ALX, for example. But what's different about this is this third column here, which includes the number of rows that were written by the pipeline. So as an example here in the historic demand table, we see that we're writing nearly 54,000 rows in the pipeline. And then we have all these blank cells here, and those indicate that those tables are not created programmatically by the pipeline. But if we were to navigate through those sheets, we would still see the columns there. While building out PyChain, we try to think about, are any of these tables ones that we could create once and then be able to reuse across projects, whether that's because maybe in the case of the objective member expression table, those are standard across ALX projects, or if there's just a way we can set the rules to define these programmatically. So the first is the agenda table that we saw on the previous slide. This is created automatically by PyChain. I already mentioned these two. The next are periods and historic demand tables. So remember I was talking about the different data layers. So maybe we're creating our demand pipeline. So we start with demand raw, then demand intermediate. And if we create demand primary, we can feed that into the associated nodes that create the periods and historic demand tables. So we were able to get those tables for free just by creating our demand primary. In a similar way, the group's customers table is created just by creating the customer's primary, and then we can feed that and create this table. The vehicle types table already has the default vehicle type with unlimited capacity. So if you're not worried about modeling your vehicles in your supply chain, you need to use just a default vehicle unlimited capacity. If you want to add that or if you want to model that with more detail, you can always add to that, but this allows you something to start from. Lastly, the scenario settings and icons tables. These are easily editable via schedule parameters. So maybe you want to change the colors of your icons. You can easily do that when running the pipeline. So why Pandera? Pandera was one of the tools I mentioned we're using this project. And why are we using it here? Pandera allows you to find pipeline errors as quickly as possible so that we don't have to troubleshoot failed ALX imports. So the goal here is if the pipeline runs, then the model can be imported into ALX successfully. And we're going to take a look at one of these Pandera data frame models. And if you're not familiar with Python, don't worry, I'm going to talk about this at a high level to see where the value of Pandera is in this. So here we're looking at the data frame model for the BOM table, the bill of materials table. This table has 4 columns: ID, name, end product, and quantity. And the checks that Pandera is doing here is the pipeline run will fail if the ID and name column are not unique, as that'll cause errors in ALX. So we want to make sure that that error is raised when we run the pipeline. In addition, the quantity column must have all values strictly greater than 0, or else the pipeline run will fail. Here at the bottom, we have some metadata, which tells us the experiments that this table is used for. So it's used for the network optimization simulation experiment, but the greenfield analysis experiment does not use this table. This is useful when we are writing our empty tables to Excel with that Excel input data set. So if maybe we're building out the demand table in our network optimization experiment, we still need to write these 4 columns to this BOM sheet in that Excel file. And so this metadata here is how we know to do that. And this isn't like a Kedjo or Pandera thing. This is something that we built specifically for PyChain. And the network optimization experiment has 58 data frame models. So there's 57 other data frame models here that are used to create this Excel input sheet. Next is the scenario manager. So the scenario manager allows us to quickly create new scenarios from the baseline model. This allows users to quickly change the factory capacity, production capability, transportation costs, and any other parameter. And the interface by which you can do so is either through Excel or through some sort of web app. And how this works is you start from your baseline ALX model, you use the scenario manager to create a new scenario, and then you can take that baseline ALX model and your scenario, and then you can import both of those into ALX to run your experiments. And Nick will give a demo of this in a little bit. So why do we use PyChain? PyChain means we don't have to start from zero. We can easily refresh the data. We can easily change model parameters using the scenario manager. And in one project, it resulted in a decreased scenario creation time of 70%. This also enables more users to create scenarios, helping our clients make optimal decisions faster. With that, I'd like to pass it over to Nick, who's going to do a demonstration of the scenario manager that I was talking through a little bit ago.
Thank you, Chris. Yeah, so as Chris mentioned, I'm going to go through and demo out a scenario manager. As mentioned in his presentation, this can be done several different ways, including using a web app, but as simple as using an Excel sheet. So with this Excel sheet, you could send it off to your different planners, your different executives, whoever wants to be able to run these different scenarios that will then come back to your ALX optimization, supply chain, strategic team to be able to run these different scenarios faster. So what are we looking at here? So this is an example of setting up different production capabilities with different production costs at each of these three different factories. So here we have three different factories, very uniquely named, factory A, B, and C. Over to the left-hand side, we have a bunch of different SKUs across three different categories. So here we have a liquid set of SKUs, a powder set of SKUs, and a set of solid SKUs that are made uniquely at each of these different factories. But what happens when you want to run a scenario? Let's say, hey, what if we add a liquid line, or what if we build a liquid line at factory B or factory C? Typically, what you would have to do is go into ALX, create a bunch of different lines in your production table, make sure everything corresponds with all the other tables, and then create a copy of it and make a new scenario. But here with our scenario manager, you can now send this off to your other team members within your organization. They could create a new tab here and then basically grab, hey, I want a new liquid line at factory C, or I want to test out, hey, should I be having a liquid line at C or B? And by copy and pasting the different production costs from A to B to C, we're now able to run the scenario because of PyChain, because of the scenario manager template. It will create those models automatically for you in the back end that you could then use and implement into ALX. So that's just one example of what this template could be used. So looking at another example, so something around like capacity, let's say. So right here, you can see that our factories A, B, and C have different sets of lines within them with unique capacities for the current year. But since we're looking at adding a new line, a new type of line, so like a liquids line at factories B and C, why don't we look out not just for this year, let's look out the next 5 years. Here we would add a new tab at the bottom, and you could fill out, hey, we're going to increase capacity in 26, 27 to 2030. And then on the flip side, hey, we want to decrease capacity and eventually get rid of a line. And we want to understand the effect that has on our supply chain as a whole. So here we can use the template to not only set your capacities for the current year, but now you could set the capacities and effect of, getting rid of a line, or, hey, we're going to add improvements to certain lines within your supply chain, within your factory network, to then be able to, create those models faster. So this is, again, something you could send out to someone, or we have built web apps in the past, so you could, have a web interface where someone will log into and change these values around, connecting to the ALX API. That way they could get those decisions faster. But let me back up here. Let me show a quick example of how this would work. So send this off to an executive. They send this back to you. You then take the Excel sheet template. You go to your VS Code or whatever coding software they use. As we mentioned, this is all built off Kdro. So then you go into your terminal, click Kdro run, and then you run Kdro. This will then run all the different checks and balances. I forgot to CD into the Kdro pipeline here. Love a live demo. So now that you run your K-drill run, you can now see the process is happening where it's going to go through all these different data layers and all these different steps, as Chris mentioned in his part of the presentation, all leading to our final ALX results, which are our set of model tables. So as you can see here, we have our historical model, so the current year model, and the 5 following years, which change all the different capacities and changing the different production capabilities at each of those factories. And because we know that all these are checked using Pandera, we can now use these models. We could just drag and drop these models directly into ALX. So, Chris, if you don't mind sharing the presentation again.
Yeah. Can you stop sharing?
Oh, yes, I can. So, why use PyChain and anyLogistix? So, what are you going to gain? You're going to get 70% faster scenario creation, as we mentioned before, which is going to lead you to get quicker data-driven decisions. Your executives are going to have immediate access to those risk trade-offs. Your planners are going to be able to run those what-if scenarios. And then your procurement team is going to be able to understand, hey, what happens when we look at different suppliers in your network? What are you going to avoid? Most importantly, longer scenario development times, which are going to lead to slower time to decisions, constrained by your team of users, which then is also going to result in your executives going off their gut feelings. Planners are going to make suboptimal decisions, and then your procurement team is just going to stay with who they've always stayed with because they don't have a way to understand, hey, what would happen if we tested out different suppliers in our network? So, if you want to save costs in your supply chain, evaluate opportunities for expansion, build scenarios more quickly, and build out your supply chain digital twin, feel free to give us a call. Over to the right, I have, or underneath me, I have a QR code that links directly to our website, our Let's Talk page. We'd love to hear from you to help solve your supply chain issues. So, with that all being said, I see in the chat that we have people literally from all over the world, which is so exciting for me. But feel free to drop any questions in the Q&A section, and Chris and I are here to answer them. I did see a question that I answered during the presentation. So, do we sell it? So, as I mentioned, the answer is everything that we build here is open source. So in theory, anyone can go in here and build out PyChain themselves. But we already did that work for you. We built it directly for anyLogistix. So feel free to come out and reach out to us, and we could help, build up your models and build up your PyChain to help solve your problems faster. Yeah. Pass it back to you, Ryan, unless I see anything else. Where can we find educational materials? Oh, okay. Now I see questions, of course, as I'm about to pass it off. So where can I find more educational materials? Okay, now they're really coming in. So right now here, feel free to just reach out. We don't have anything. I know we're coming out with a blog later this month all about PyChain. So feel free to look at our LinkedIn. We'll definitely have that posted, and definitely on our website we'll have posted. Alrighty, let me go to Roman's question. Nick, Chris, I wonder if you use those frameworks only preparing for data for your projects, or also supply those data preparation scripts to the end client along with ALX scenarios. So yeah, it all depends on what you want to build and how you want to build it. So we have certain clients that just want us to build it and give them answers. This is us so we can internally be able to be able to build these models faster. But also we have we do teach you how to fish. So we do have certain projects where we will help you implement something like PyChain. That will do all the data cleaning for you. That way, when you guys get it on your end, you're able to, run the tool, be able to get your ALX models faster, or we could just build you guys templates with these models or help you build out more templates so you guys can, get those data decisions faster. Cool. And then I got another question from Jan. Uh, do you use these models in warehousing too? For what kind of decision support? So yes, we can. We have built templates where we can do the quickly enable and disable different warehouses, or add a list of types of warehouses and locations that we can dynamically add into ALX. So instead of what you saw there in capacity or the production table, you could just make a stream of lists of different DCs and warehouses, and then that could go into consider like an asset constrained scenario for those who have joined me or Decision Labs in training. That is definitely something that we could do as well. You can also play with different throughput capacities. I'm trying to think of other warehousing type things. Different inventory policies as well. You can implement as far also with the scenario template and the scenario manager, all built to run naturally through PyChain. So feel free, more functional. Sorry, I got the response here. Your answer is more in function of distribution networking, but do you also do warehouse internals?
I
Oh,
can speak to that.
yeah. Go, Chris.
Yeah, so last year we did build a simulation of the internals of a warehouse. So it was at the ski level, and you'd see like forklifts moving things around. And I actually did use Kedjo to pre-process the data that was feeding into that simulation model. So you can use Kedjo for anything, but it was not PyChain specifically. So yeah.
Perfect. So
All
is
right.
it, what was that?
There's another question that I can answer.
Sure, go.
Yeah, so there's a question in the chat. Is the solution designed to make operational usage easier? And what problem are we solving by introducing this framework? So there's a couple problems that are being solved by it. So there's like the the short answer is quicker time from question to answer. But basically, we're not starting from scratch when we're starting a new ALX project, or we're not starting from scratch if we're creating a new scenario. And in addition, um, uh, yeah, I think that answered it. And so the problems is mostly the time it takes to build something, and then also adding those checks in for data quality to make sure that we're not trying to feed in bad data into our scenario.